Good day everyone, you're welcome to today's tutorial. This is Mathematics Clinic by Tutor Chris. Okay, if you are new to this channel by any means, kindly subscribe to the channel now. And if you are just watching me for the first time, this is Mathematics Clinic. Make sure you subscribe and turn on your notification. Alright, so in today's tutorial, I want to recreate this problem. I've done it before, okay? But some of my viewers, they said they want me to recreate it. So this number one, I want to recreate it, okay? And I want to add another one to it today. You can see this is variable. The first one says log over 2x minus 5 to the power of 7 base 3 equals to 21. That's the one I said I want to recreate, okay? And now the second one, if log over a plus 3 minus log b base 9 equals to c plus 1 over 2, and log over a minus 3 plus log b base 3 equals to c minus 1. Show that a to the power of 2 equals to 9 plus 27 to the power of c, and find the possible values of a and b when c equals to 1. Okay, so now let's solve the problem together. All right, let's start from the first one. Okay, so now the first one, we're having that should be solution. All right, now having log over 2x minus 5 to the power of 7 base 3 equals to 21. So let me rewrite that. Log over 2x minus 5 to the power of 7 base 3 equals to 21. All right, now don't forget that the law of logarithm allows us to take the exponent to the back here. Okay, so that's what I want to do now. I will take the exponent, which is the 7 here, to the back of the log here. So that will give me 7 log over 2x minus 5, okay, base 3 equals to 21. All right, that's cool. Now I can still divide both sides by 7 so that I can eradicate this 7 at the back here, and I will divide this by 7 too. Okay, if I do that, everything divided by 7 divided by 7, 7 will cancel out here. I'll be left with log over 2x minus 5 base 3 equals to, 27 divided by 21 divided by 7. That's going to give me 3. Okay, I'm going to have 3. All right, now don't also forget the law that log over a base a equals to 1. Okay, now that also shows that log over a to the power of 3 base a equals to 3. The 3 can come here, and log of a base a will give us 1. So 1 multiplied by 3 equals to 3. So I'm going to apply this to what I'm having here now. Okay, that's what I want to apply to it now. Now that means I can turn this right hand side also to log over base 3. So this will be log 2x minus 5 base 3 equals to, instead of having 3 now, this will be log of 3 to the power of 3. Okay, base 3. Okay, and this is also same thing as what? Log over 27 base 3. Okay, don't be confused, we are still having the same thing. Now let's go on. Now if I say I'm having this log to base 3 can cancel log to base 3 here, so I will left it 2x minus 5, okay, equals to 3 to the power of 3 is 27, so I'm going to have 27. Okay, and now you can see we are getting to where I'm going now. Okay, I will collect the like times. This will be, or I can collect the like times. So let me say I add 5 to both sides. 5 is going to cancel out the 5 here, so I'm going to have 2x equals to 27 plus 5. My God, I hope you understand what I just did there. Okay, and 27 plus 5, that's 32. So I'm going to have 2x equals to 32, and if I divide both sides by 2, divide both sides by 2, this now implies that 2 is going to cancel 2, and I will be left with x, and 32 divided by 2, that is going to give me 16. So x equals to 16. Okay, which is the solution to this variable problem. And you can also check. How do you check? Okay, if you want to check now, we are giving log over 2x minus 5. Oh, sorry, minus 5 to the power of 7 equals to 21, and this is base 3. Okay, don't forget I said we can write this as 7 log over 2x minus 5. Okay, base 3 equals to 21. Okay, what we're having on the left hand side here, everything will be equals to 21. That's what we want to do now. Okay, now we already said that our x is 16. I want to check if that's correct. So that will be 7 log to base 3 of 2 into bracket over 16, okay, minus 5. Is this equals to 21? That's what I want to check. Now this will be 7 log to base 3 of 16 multiplied by 2, that's 32, okay, minus 5 equals to 21, and this will be 7 log over this. Now of course 32 minus 5 is going to give us what? 32 minus 5, that's going to give us what? Okay, that will give us 27, okay, base 3. Okay, what we are trying to show is that everything at the left hand side, don't forget, must be equals to the right hand side. So now this is 7, this can be written as 3 to the power of 3 base 3 equals to 21. And if I do this, the law of our logarithm allows us to bring the exponent to the back here. So I'll be having 7 multiplied by 3 log 3 base 3 equals to 21. And don't forget the variable concept I just showed us here, that is log of a base a. Okay, log of a base a is equals to 1. So now this shows that I'm having log of 3 base 3, which is 1. So that's 7 multiplied by 3 multiplied by 1 equals to 21. 7 multiplied by 3, that's 21. Multiplied by 1, that's 21 equals to 21. You can see that's correct. Okay, now let me move to the second problem here. Oh my god. I love that problem. Okay, now let's move to that. Permit me to clean everything here, so that, because I'll be making use of a lot of space to solve that problem. All right, now, so I'm giving this is two equation now. Log of a plus 3 base 9. This is the first one. Let me see number 2 now. First equation, that is the first equation. The first equation equals to log of a plus 3 base 9 minus log of b base 9 equals to c plus 1 over 2. And the second equation, of course, I'm having okay, the second equation, of course, is that I'm having log of a minus 3, okay, a minus 3 base 3, okay, plus log of b base 3 equals to c minus 1. So these are the two equations we are given in this problem now. Okay, now let's convert this into something variable now. So now from this equation 1 now, I will turn this to something variable now. Don't forget this is now log okay, this will be log to base 9 of a plus 3, my god, a plus 3 minus log b base a. Okay, now I can subtract this from this. Okay, that's minus, that is I collect the like time minus r equals to c. Okay, and I can do the same thing to this second equation now. This will be log to base 3, okay, of a minus 3 plus log b base 3 equals to plus 1, collecting the like times, equals to c. Now you can see that this is getting more interesting now. Okay, now also don't forget that log of 2 base 4, let's say log of 2 base 4 equals to x. Okay, now this is same thing as 2 equals to 4 to the power of x. Don't forget. So I will clear out the log now. This is 2 equals to 4 to the power of x, and then this will be 2 to the power of 1, the same thing as 2. to the power of 2 to the power of 2x, okay? Because I want them to have the same base. No equal bases can cancel out. I'll be having 1 equals to 2x, okay? And I'll divide both side by 2, divide both side 2, x equals to 1 over 2. Oh my God, you can see that now. So that's what I want to do to this negative 1 over 2 now, okay? Look at it again. I will show you that one too. All right, now, I can also represent this as this 1 over 2 as log over 3 base 9, okay? Why? Because log of 3 base 9 now set equals to x. This will give me log over, this will give me, 3 equals to 9 to the power of x. And then I want them to have the same base. Don't forget, 3 to the power of 1 is same thing as 3. So I'm having 3 to the power of 1 equals to 3 to the power of 2x, so that they can have the same base. And now this equal base will cancel out. I will have 1 equals to 2x. And then if I divide both side by 2, divide both side by 2x equals to 1 over 2. You can see. All right. So now that's what I want to apply to that first equation. So the first equation now becomes, this now becomes, okay, log of a plus 3 base 9 minus log over b base 9 minus, now instead of minus 1 over 2, I will write log over 3 base 9, okay? Log of 3 base 9 equals to c. You can see everything is in form of logarithm now. So that's what I want to do. I want to achieve this because I want them to look alike. Now, I also apply the same thing to that variable equation 2. No, don't forget that log of a base a is also equals to 1. So that tells us that log over 3 base 3, that will be equals to this 1, okay? So now this second equation now, of course, will now become log over a minus 3 base 3 plus log of b base 3 plus log of 3 base 3 equals to c. Oh my God, everything now is set to logarithm, okay? Now this is variable. Now let me move to this second page here, okay? I'm having that for the first equation, this for the second equation now. And don't forget log of, let me rewrite that here, log over a plus 3 base 9, okay? And then plus log over b base 3, okay? Base 9, sorry for that, base 9, okay, minus, is it even plus? Oh, sorry, this one I'm writing, this one I'm writing. So this is minus log of b base 9, I'm so sorry, okay, minus log over 3 base 9 equals to c. And then the second one is log over a minus 3 base 3, okay, this 3 base 3, okay, and then plus log of b base 3, okay, plus log over 3 base 3 equals to c. All right, this is very well. So I still want to show you guys something about these two equations now. So this first equation, according to the law of logarithm, minus means division and then plus means multiplication, okay? Now, so now this means that I'm having log of this will be a plus 3, this is minus, that is divided by b, okay? This is also minus divided by 3, so that's multiplied by 3 now, that's 2 division now, okay? Don't forget this is base 9, that's very, very important, equals c. All right, now, and this second one also will become this, that is log of a minus 3 all divided by, a minus 3, this is plus, that is multiplication dot b, this is plus, that's also multiplication in logarithm, so multiply by 3, okay, to the power, to the base of 3 equals to c. Oh, wonderful, this is making sense now. I don't know if it is making sense to you. Now let's move on. Since we're having this can be reading as the first one here can be reading as, that is a plus 3 over this. No, according to the law of logarithm now, there is variable concept I applied there. That is, if you're having let's say you're having log of 2 base 4 equals to x. You know, this is log of this is x equals to, oh sorry, this is 2 equals to 4 to the power of x. Okay, that's what I want to apply to the first one, and I will do the same thing to the second one. Okay, now this first equation now will become a plus 3 divided by b plus 3 equals to this 9 to the power of this, now 9 to the power of c. Okay, I will get that now, so I can now call this equation 1. My god. Now what about the second one? Now can you give that a try and let me know what's here. Now, without wasting much of our time, this will be, you know, b multiplied by 3, that's 3b. So I'll be having a minus 3 into 3b equals to, you know, this 3 to the power of c now. Okay, 3 to the power of c, which is my new equation, which is equation 2. That's cool. This is exactly where I'm going. Okay, now let me clean all this. I want to write it now because I'm getting closer to the destination. Oh my god, I'm happy. Now let me rewrite this. This is oh my god, a plus 3 over b plus 3. Okay, oh, b multiplied by 3. Abi, this is b multiplied by 3, which is 3b. Okay, 3b equals to 9 to the power of c. Okay, equation 1, and then equation 2, which is a minus b minus 3 multiplied by 3b equals to 3 to the power of c, which is equation 2. Okay, wonderful. All right, just make sure you keep on following. In fact, if you don't get all of the concept, make sure you keep following. Along the line, you will understand what you are doing. Okay, now I'm having this. So I can multiply equation 1 with equation 2. So multiply, don't forget, our aim is to show that a to the power of 2 equals to 9 plus 27 to the power of c. Okay, that's our aim. And then after that, I'll find the possible values of a and b. So that's what I'm trying to achieve now. So multiply equation 1 by equation 2. Okay, now if I multiply equation 1 by 2, don't forget equation 1 is 1 plus 3 over 3b, and then multiply by equation 2, which is a minus 3 into 3b, okay, equals to 9 to the power of c multiplied by 3 to the power of c. You know, that's multiplying equation 1 and 2. Now this can cancel out this 3b divided by 3b. Okay, I'll be left with a plus b, a plus 3 multiplied by a minus 3 equals to, you know, this now can be expressed as, you know, 3 to the power of c is same thing, 9 to the power of c is same thing as 3 to the power of 2c. Okay, multiplied by 3 to the power of c. And according to the law of indices, this is now 3 to the power of 2c plus c, which is equal to 3 to the power of 3c. And 3 to the power of 3c is same thing as, you know, this is 3 to the power of 3, okay, and then to the power of c. You know, 3 to the power of 3 is 27 to the power of c now, so I can have 27 to the power of c. Okay, that's what I want to show you. Now, of course, this is equal to 27 to the power of c. That's beautiful. So I'm now having this equals to this. Let me clear that out now. So this is equals to 27 to the power of c. That's cool. And don't also forget this concept, that is a minus 1 and then a plus 1. This is going to give us a to the power of 2 minus 1 to the power of 2. Okay, and minus 1 is going to give us what? You know, 1 to the power of 2 is same thing as 1. So now if I do this, this is a multiplied by this, so I'm going to have a to the power of 2 and then minus 9. Okay, that's what you are going to have. And you can do it, that is, this is multiplying this and then multiplying this and then multiplying this and multiply this. Okay, this is what you are going to have. A to the power of 2 minus 9 equals to 27 to the power of c. You can see I've showed 8 to the power of 2 minus 9 equals to 27 to the power of c now. Of course, now if I collect the like time, this is 8 to the power of 2 equals to 27 to the power of c plus 9, which is what you are asked to show. So I've showed that, this is addition is commutative. So I'm having 27 to the power of c, 9 plus 27 to the power of c is same thing as 27 to the power of c plus 9. Okay, I've showed what they asked me to show for the first time now. Now, the next thing is to find the possible values of a and b when c equals to 1. What will be the possible value of a and b when c equals to 1? Now, let's come back here. Our 8 to the power of 2 equals to this. When c equals to 1, so we can quickly find our a. A is to the power of 2 equals to 27 to the power of 1 now, since c is 1 plus 9, okay? Plus 9. And this is going to give me, 9 plus 27, that's 36. Okay, I'm having a to the power of 2 equals to 36. Okay, and if I find the square root of both sides, find the square root of this is cancelling this. So I'll be left with a equals to plus or minus 6. Okay, that's our answer for a. A is plus or minus 6. But at the same time, when our a is minus 6, that's not possible. Look at what we're having here. This will not exist. A plus 3, a minus 3, this will not exist. Okay? So that shows that our a can only be positive 6. And if our a is equal to positive 6 now, let's come to this equation 2 now. If our a equals to positive 6, what will be our b now? So that's what I want to show now. Okay? Now, this will be, let me clear this page. All right, now, so if our a equals to positive 6, I will insert it into equation 2. That is, so, equation 2 is a minus 3, okay, to the power of, multiplied by 3b equals to 3 to the power of c. That's our equation 2, okay? But our c is 1, and a is known to be positive 6, because we said minus 6 cannot fit into this one exists, okay? Now, we are going to have our a, which is positive 6 minus 3 into 3b equals to 3 to the power of 1, since c is 1. So this is now, 6 minus 3 is 3 multiplied by 3b, okay, equals to 3 to the, because 3 to the power of 1 is same thing as 3. Now this is 9b equals to the 3, and then I can divide both sides by 9, divide both sides by 9. B will be equals to 3 over 9 is same thing as 1 over 2. So therefore, a equals to 6, and then b equals to 1 over 3. Alright, this is the solution to this variable problem. If you like this video, make sure you subscribe to my channel, share to your friends. Thank you. See you next time. Bye bye.